Hello everyone, welcome back to our channel. Today we are diving into one of the most important concepts in material science, that is relation between cold working and yield strength and ductility. This graph actually says it all. But don't worry, I will break it down for you in the simplest way possible. Okay, so look at this graph. On the x-axis we have percent cold work, which represents how much a metal has been deformed plastically, thinking of rolling or hammering or drying the metal at room temperature. And on the y-axis, we have yield strength, which tells us how much stress a material can handle before it's break or deform, basically permanently. Okay, so before permanent deformation, whatever the material sustain the stress, that is yield stress. Okay, now observe these three curves. One is for 1040 steel, okay, other is for brass and other is copper. As the cold work will increase, you can see as we are moving left to right on x-axis basically. So as the cold work increases, what happens? All the three metals like steel, brass and copper shows a clear increase in their yield strength. Yes, so their yield strength is increasing and that's expected. Cold working makes the metal harder and stronger due to we can say dislocation, entanglement and grain distortion, right? Okay, but here is the catch, and that is really important. Okay, what is that? There is no such things just like a free lunch, right? What does mean that in material science, if we are increasing the yield strength, here we are increasing the yield strength, okay, by doing the cold work, okay, but we have to pay it by losing what? Ductility. So when we increase the yield strength by cold work, so ductility decreases, yes, as well as brittleness, brittleness increases. Okay, so it's true that there is no free lunch. Like if we are trying to increase the yield strength, then we have to lose the ductility and also brittleness will increase. So while the metal becomes more stronger, okay, because the higher yield strength we are getting, but it becomes more likely to crack under stress instead of bending. Okay, now why this happens actually? Okay, because whenever we do cold working stores energy in the form of internal strain, okay, and defect inside the metal crystal structure, and the more you deform it, the more unstable and brittle it becomes, right? Now how to fix this increased brittleness and decreased ductility? Here we can do one process, that is what? Annealing. Annealing is actually a game changer. Okay, if we heat the cold work metal, all this cold work metal, right, to about one third to half of its melting point, one third or we can say half, okay, of its melting point actually, the stored energy is released. Whatever the stored energy that is released in the cold work material is released. Okay, stored in the cold work material is released. This process allows the atom to rearrange again and it changes the microstructure, making the metal more stable and closer to equilibrium. So as a result, what will happen when we do the annealing? What will happen? Annealing will result into increase in ductility. So ductility will increase, brittleness will decrease, and we get a better combination or we can say a balance between strength and flexibility. So it will be more flexible, flexibility increases, and we can say it's a better combination of both. Okay, so that's why we can say annealing is such a crucial step after extensive cold working. Okay, so to wrap it up, cold working increases the strength, we know, okay, but reduces its ductility. And then here the game changer that comes is annealing, which helps restore that lost ductility by allowing the microstructure to relax. So next time you see a hard metal object, remember that the strength may have come at the cost of its flexibility. Thanks for watching. If you have found this useful, don't forget to like, share and subscribe for more such science made simple videos. See you next time. Thank you.